Hi, this is Michelle Cullen. Welcome to Astronomy 103A, based in Prince William Sound Community College in beautiful Valdez, Alaska. This week we're going to expand on the Jovian planets that I started on last week and spend more time on the planetary rings and the Jovian moons. This video lecture covers the planetary rings that range from spectacular to invisible. Did you know that all four of the gas giants have rings? Most people think of planetary rings. They visualize this, the stunning picture taken by Cassini of Saturn, and you can see down below its moon, Mimas, just underneath. But we also find that the other three Jovian planets have rings as well. This is an image of the planet Jupiter taken by the Hubble, and it can show this faint rings here that are made out of microscopic particles of dust. This is the planet Uranus with its Shakespearean named moons, and it has a thin, very faint ring that's best seen here in this image taken by Hubble. Here's a Voyager 2 image of the rings of Neptune that are almost invisible except when taken from the vantage of the spaceship nearby. As a matter of fact, Voyager 1 was the first way that we discovered the rings of Jupiter, Uranus, and Neptune. These images sent back in 1971 from Jupiter showed that the rings weren't very bright because they were made up of microscopic rock and dust particles. Here's a beautiful image of Jupiter's rings. One way to describe why you can see them better from the spacecraft was that if you have a beam of light that's shining through baby powder that's been sprinkled into the air, you could see that the fine particles would light up and make the beam visible. Well, that's exactly what was happening when Voyager passed beyond Jupiter and had the light shining through these gossamer rings. You can see there's the gossamer rings, the outer ones, the main ring, and the inner halo. So the rings are made out of dust that would eventually fall back into the gravity well of Jupiter. So the rings have to be constantly resupplied with dust, probably from the impacts of meteors. The asteroid belt is nearby. There's comets going by too, so all of these could impact on form new sources of dust. Well, why is Saturn so lovely? This is an image taken by Voyager 2 through a spectrograph, and it's looking at the different chemical composition from one part of the ring to another. And these are all different types of ice with different chemicals in them, which show up on the spectrograph as different colors. So the main reason we can see it from Earth so clearly is that Saturn has rings made of sharp crystals of tiny chunks of ice. And these ice chunks are constantly hitting each other and breaking apart and freshening up. If they were not being hitting each other and opening up the ice, then it would become dusty and the rings would become dark and hard to see. In this close-up image from the Cassini mission, the rings are seen to be divided into many individual rings separated by narrow gaps. The large gap you see here is a Cassini division. So another interesting fact is too that because that Saturn is tilted 27 degrees, as it comes around at the equinox, we're viewing Saturn from edge on, and it makes it possible to see how very thin the rings are. They're actually less than 100 meters thick. It's just this edge is only 100 meters. When you consider how big the planet is and how that the diameter of the rings, 270,000 kilometers in diameter, the analogy would be that the thickness is like a sheet of paper, 1 millimeter thick and 10 kilometers wide. So they're extremely, extremely thin. They're kept together by shepherd moons that help create the gaps and also help create the sharp edges. The gravity of the moons keeps the dust from spinning away into space, and it will eventually go back in towards the planet and have to be replenished. The invisible rings of Uranus and Neptune share many characteristics. They both have narrow, dark rings separated by large gaps. The thin rings of Uranus have this tilt and a slight eccentric orbit, which isn't surprising because we know that Uranus is tilted on its axis, rotating almost 90 degrees as it travels around the sun. Well, how did they discover them if they're so faint and so far away? Well, the answer was that there was going to be a star passing behind Uranus, and so scientists were watching it on Earth-based telescopes, and they saw that the star didn't just blink once as it went behind the cloud, or behind the planet. It blinked 9 times as it went through the different rings. So that was how it was discovered, and the same thing was true for Neptune as well. Except for Neptune, it showed that it looked like it was an incomplete ring that was an arc. It took Voyager's spacecraft to clarify that there seemed to be incomplete arcs on Neptune. And here's an image from the universe today of the rings of Neptune and showing the moons as well. So now we can see the differences between the dusty rings of Jupiter, the brilliant icy ring of Saturn, the small, dark, thin images from the rings of Uranus and Neptune. The last question I have for you is that why do the rings exist at all? Well, I've given you some of the clues in this last few minutes, but why don't terrestrial planets have rings? That's a topic for you to look into and think about and reflect in your discussion in your weekly reflective journal. Hope you enjoyed this lecture, and I hope you enjoy learning more on your own about these different planets and their moons.